The last mode of heat transfer is called radiation, or thermal radiation to be exact. From our previous discussion, we said that thermal radiation occurs when thermal energy is emitted by an object in the form of electromagnetic waves. The most common form of thermal radiation that we are all familiar with is solar radiation. Now, unlike conduction and convection, no intervening medium is required for thermal energy to be emitted by an object and for it to travel from one point to another. The only requirement is for the body to have a temperature greater than the absolute zero temperature. This means that practically all living and non-living things emit radiation, although at varying degrees. The principle governing thermal radiation is the Stefan Boltzmann Law. This concept allows us to compute for the maximum rate of thermal energy that can be emitted by a black body at a certain surface temperature. Now, if you analyze carefully from this definition, radiation and convection are the same in one thing. Both modes of heat transfer are surface phenomena. That is, they can only occur at the surface of the object. Now, you may ask, what is a black body in the first place? Can we consider all black bodies to be automatically, can we consider all black objects to be automatically black bodies? Well, the answer is no. Black bodies are objects that can emit thermal radiation at the maximum rate given by the Stefan Boltzmann law at its given surface temperature. You can think of it as an ideal surface, and the sun is a good example of this. Now, what are real surfaces? In the, in the context of radiation heat transfer, these are surfaces which emit radiation at a lower rate than an idealized black body. To relate the amount of thermal radiation emitted by real surfaces to the maximum amount of radiation emitted by a black body at the same surface temperature, we shall define another thermal property. This is emissivity, and it is denoted by the Greek letter epsilon. Like thermal conductivity, this is solely a property of the material only, and its magnitude is dependent on the surface material and on whether the surface is rough or smooth. Through this property, we can now write the formula for the thermal radiation emitted by a real surface in this way. Now the value of epsilon is obviously equal to 1 for a black body, while it is between 0 and 1 for a real surface. Another way by which we can express the rate of emitted radiation is on a per unit area basis. We refer to this as a surface emissive power, and we denote this as Q over dot sub emit double prime.